Hi everyone, welcome to GoClasses. In this session, we will see our Boolean algebra weekly quiz solutions. Okay, so let's start. Let's solve this question. Function f a b c. This is given to you. This is a or b or c. What is the value of f with these arguments? So this is a very simple question. So this Boolean function is given to you where a, b, c, these are the variables, these are the Boolean variables, and this function is defined on these Boolean variables a, b, c, and function is basically a or b or c. Now the question is saying that what is f, a, b, a, b bar? Very simple. See, the function is like this. F, A, B, C. This is A or B or C. Now the question is asking what is F, A, comma B, comma A, B whole complement. This is what the question is asking. Very simple. So you can see A is as it is, B is as it is. So it will be A or B. But remember, instead of C, what we have? Instead of C, we have AB whole complement. Okay, this is what we have instead of C. Okay, instead of this C, we have AB whole complement. So very simple. Now, what it will be? It will be A or B or. Now, what is this? AB whole complement. You can apply the De Morgan law. So it will become A bar or B bar. This is what it will become. So it will become A or B or A bar or B bar. Okay. Now you can easily see that you can apply the commutative property. You can basically write like this A or A bar or B or B bar, and this will be what is A or A bar? This is very simple. This is 1. And what is B or B bar? This is also 1. 1 or 1, what is that? That is 1. Okay. So here answer will be option B. So this is a very simple question. Now let's move on. Let's solve this question. What is the simplified form of the Boolean expression? This Boolean expression is given to us f, x, y, z, and the question is asking what is a simplified form. So let's solve it. The Boolean function that we have, that is f x y z equal to x y z. Okay, so let's see this. F x y z, that is equal to x y z or x bar or y z whole complement. Okay, x bar or y z whole complement, or x bar y whole complement, and then there is z. Okay, so this is the function that is given to us. Now let's simplify this. Here what we can do, this will be x y z. Now what we can do in this, okay, you can apply the De Morgan law. We already know that alpha or beta whole complement, that is alpha complement or beta complement. Okay, we also know that if you have alpha double complement, that is equal to alpha. So all these things we already know, so you can apply them. And what we will get, so here we will get that if you apply the De Morgan law, then it will happen like this: complement of x bar, so that will be x. Okay, this or will become and. What will happen? And here you will have yz whole complement. Okay, yz whole complement, right? Now remember, yz whole complement, you can write it y complement or z complement. So what you can do, you can write it y complement or z complement. So like this you can write. Okay, see this, xyz or x bar or yz whole complement, x bar or yz whole complement. Or let me check the question. Is the question correct? Yes, the question is correct, right? I've written everything correctly. Okay, here alpha or beta whole complement, that will be, so De Morgan law, alpha or beta whole complement, that will be alpha complement and beta complement. This is the De Morgan law. Okay, now you apply this De Morgan law, what will happen? So you will get this x bar whole complement, that will be x. This or will become and here you will have yz whole complement, that is y complement or z complement. What you will get here, you can apply the De Morgan law. Again, you can apply the De Morgan law. So you will get x or y bar z, right? Yes or no? So if you simplify, what you will get? What you will get? Here you will get x y bar or x z bar or x z or y bar z, right? Correct? Okay. So very simple. This is what you will get from here, x z or y bar z. And this is what you will get from here, x y bar or x z bar. Okay, so now what we can do here, Now further, how can we simplify? Very simple. Here you will get x, correct? Okay. See, we have x y bar, sorry, xz bar or xz. Okay, we have xz bar or xz. Here you can basically take x common. You can take x out. Okay, what we will get? We will get x, z or z bar, and that is x and 1, and that is same as x. Okay, so remember this expression, this will become x. Okay, this will become x. Now, this I'm writing here x, or we have x, y, z, we have x, y bar, we have y bar z. Now you can apply the absorption property. Okay, on this expression, you can apply the absorption property because you can see here you have x. What we have? We have x here, x here, x here. Okay, so you can apply the absorption law, and when you apply the absorption law, you will basically get x, and you have y bar z. So this will be your final answer. Remember, we have absorption law. What is absorption law? This absorption law basically says that if you have x or x bar or xy, okay, if you have x or xy, if you have this type of expression x or xy means this x or xy, then you can simply write it x. So remember, if you have x or xy or xz or anything x, anything alpha, x, anything gamma, okay, this whole thing will become only x. Okay, because you can see you have this x here, x here, x here, x here, x here. So you can apply the absorption law. This is basically x or xy equal to x. So you can apply this. Here you will get, this is your final answer, x or y bar z. So answer will be option B. Okay, is this clear? Very simple question. So this Boolean function is given to us and we need to simplify this. The answer will be x or y bar z. Very simple. Now let's solve this question. If the Boolean function f equal to, this Boolean function is given to you, what is the value of f and f bar? This is what the question is asking. The question is asking what is the value of f and f bar. Tell me, does it matter what is f? Let me know. See, this f is a very big expression is given to you. A very big, very complicated expression is given to you. Okay, there are 5 variables a, b, c, d, e. Tell me, does it matter what is f? Does it matter what is f? It does not matter. F and f bar, that will always be 0. F and f bar, that will always be 0. It does not matter what is f. Because very simple point, that if you have a function, like for example, you have a function on these variables a, b, c, d, e, these variables. Okay, some function you have. It can be any function. Okay, you have some function you have. Now, if I ask you what is f and f bar, remember, your function is f, and these are the variables a, b, c, d, e. These are the variables. So how many rows will be there? Please tell me. In this truth table of this function f, how many rows will be there? There will be 2 power 5 rows. Correct? Okay. Because this function is on 5 variables. Okay. You can see. Now, you can see that what will be f bar. Okay. And then you find what is f and f bar. So you can easily see that if f is 0 for the first row, if f is 0, then f bar will be 1. That we already know. Similarly, if this is 0, this will be 1. If this is 1, this will be 0. If this is 1, this will be 0. If this is 0, this will be 1, and so on. And so on. Ultimately, what will happen? F and f bar, that will be all 0. Okay. F and f bar, that will be all 0. Very simple. So very simple point, that whatever f you take, f and f bar will always be 0. Is this clear? Okay. Whatever f you take, f and f bar will always be 0 for all f. This will happen for all f. Whatever function you take, this will always happen. So this is a very simple question, and in this question, basically this question is to check your presence of mind. Remember, in this question, this complicated function is given to you. This expression does not matter. Okay, this expression does not matter. Whatever function you take, f and f complement will always be 0. So the answer will always be option D. Whatever function f you take, this f and f bar, this will always be 0. Very simple. Now let's move on. Now let's solve this question. Consider the function fxy, where this symbol is exclusive or operator. Fxy is given to you. This is a function on two variables. The question is asking what is f1y and f0y. This is the question. Now let's solve it. See, the question is saying fxy is already given to you. A function on two variables. This is function that is saying that xy exclusive or x bar or y, exclusive or x or y bar, exclusive or xy bar, exclusive or x bar or y bar. Okay. So this is the function that is given to us. Agree? Yes or no? Okay. Now, so our function that we have, this is our function. So we have written this function. Now the function is very simply asking, the question is simply asking what is the value of f1y. Okay, you find this f1y and f0y. Okay, this is what the question is asking, what this will be, f1y and f0y. Okay, a very simple thing I'm asking you, tell me, what do you think about this? Tell me, if this is 0, what value it will have? See, if this is 0, if this expression is 0, then can I say this will be 1? Just check these two, x bar or y, x or y bar. See, if this is 0, if this is 0, then it means y is 0. Okay, so it means it will be 1. If this is 0, it will be 1. Tell me, if this is 0, then what will be this? If this expression is 0, then this expression will be 1. If this expression is 1, then what will be this expression? If this expression is 1, then can I say something about this expression? For example, if y is 1, and let's assume x is 0, if y is 1 and x is 0, okay, then in that case, this will be 1 and this will be 0. Okay, and if y is 1 and x is also 1, yeah, okay, so no, we cannot say anything here. No problem. Okay, no problem. So let's solve it. Anyway, this is not a complicated question. The question is asking what is f1y. Okay, so let's see what is f1y. Let's find it. And then we will find what is f0y. We will also find what is f0y. Okay, let's solve it. So what will be f1y? Let me know. What is going to be f1y? So very simple. Basically, x, you have to replace this x with 1. Okay, so what you will get here? 1y, that is same as y XOR. What you will get here? Remember, x is 1. Okay, so it will be simply y XOR. XOR. What will be this? Remember, x, I should put x equal to 1. Okay, x equal to 1. So it will be simply 1. XOR. What you will get here? X equal to 1. So you will get y bar XOR x equal to 1. So you will get y bar. Okay, this is what you will get. Now you tell me. Now, what is this one? So very simple point. Y or y XOR y. What is this? Let me know. Y XOR y. This will be always 0. Okay, this is XOR operator. If the inputs are same, then it will be 0. Okay, these are same, so XOR will be 0. So this will be 0. Okay, and what about this one? What about this one? Again, this also will be 0. Okay, yes or no? So very simple. I can simply say that it is 0 XOR 1 XOR 0. Now what is that? Now what is that? Very simple. This 0 XOR 1, this is simply 1. So you will get 1 XOR 0 and that is simply 1. So you got 1 here. Yes or no? So remember, F1y. F1y. This is, okay, this expression. What is this expression? This expression is 1. Now let's see what is f0y. Let's find out f0y. Remember, I should put x equal to 0. If I put x equal to 0, here I will get 0 XOR. I put x equal to 0, then here I will get 1 XOR. I put x equal to 0, then here I will get y bar XOR x equal to 0. Okay, x equal to 0. Correct? Yes or no? Now, very simple. What will be this? 0 XOR 1, this will be 1. Okay, similarly, this 0 XOR 1, this will be 1. So finally, I will have 1 XOR y bar XOR 1. And I can write it y bar XOR 1 XOR 1 because XOR is associative and commutative. We already know this XOR. This is associative and commutative. Okay, so I can do like this. Now, very simple. This 1 XOR 1, this is 0. And I got y bar XOR 0. Now, what is that? Y bar XOR 0. Very simple. See, XOR with 0, that will be y bar. Okay, because you can see whatever I put here, that will be my answer. See, very simple. If I put 1 here, then I will get 1. If I put 0 here, I will get 0. So whatever I put here, that is my answer. So that is the reason I got y bar. Okay, is this clear? So here I can simply say that this expression will be y bar. Now finally the question is asking what is 1 and y bar, and that is same as y bar. So for this question the answer will be option D. Is this clear? Very simple question. Remember, this expression is given to you fxy. All we need to do, just find what is f1y, what is f0y. Okay, f1y will be 1, f0y will be y bar. This is a very simple question. Okay, let's move on now. Let's solve this question now. Which of the following Boolean equations is or are correct? Some Boolean equations are given to you. Which of them are correct? Let's check. Xy or xy bar, that is equal to x. Is this correct? Tell me. The first one, xy or xy bar is equal to x. Yes, this equation is actually correct because you can take x out. Okay, what you can do here? Here you can take x out, x common. Then you will get x, y or y bar. And that is same as x and 1. X and 1 is equal to x. So very simple. This is your option number 1. Now let's see option number 2. So remember which equations are correct. The question is asking which are correct. So option A is definitely correct. What about the option B? X or y bar equal to y. Let's see this one. X or y bar equal to y. This equation is wrong. Okay, this is a wrong. Why this is wrong? So you can easily see what will be x or y bar. This actually will be equal to x. Okay, because what you can do, you can apply the distributive law. So you will get x and x, or x and y bar, or y and x, or y and y bar. Okay, now this y and y bar, this is 0. This x and x, this is x. So finally I will get x or xy bar or xy or 0. Now you can apply the absorption law. This will be x. This will be x. So finally you will get x. Okay. So here you can easily see that this option is actually wrong. Okay. Remember, here we are applying the absorption law. What is absorption law? Tell me. We are applying the absorption law. The absorption law is basically very simple. That is x or xy, that is equal to x. This is what we are applying. Means x or x anything, or x anything, that is equal to x. Okay. So this is what we are doing. This is we are applying here. So here you will get x. So very simple, that option B, that is false. What about option C? XYZ or x bar y or XYZ bar. Let's see option number C. Option C is saying x, y, z, x, y, z, or x bar y, x bar y, or x, y, z bar. What is this equal to? Can I say this is equal to y? Okay, let's check. Let's check. Can I say this is correct? Okay. So what you can do here, this x, y, z, or x bar y, or x, y, z bar. Okay. See what you can do here. You can write like this. You can write like this, that x, y, z bar or x bar y. Now look at these two. These two will give you x, y. Okay. These two will give you x, y. What is the reason? Let me tell you the reason. See, these two will give you this xyz or xyz bar, right? Okay, so what this will give you? Here you can take xy out. You can take xy common or xy out. So this is what you will get, xy and 1, that is same as xy. Okay, so you got xy here. Now finally what we will get? We will get xy or x bar y. Now that will give you y. The same thing, xy or x bar y. You can take y out. Okay, this y, you can take it out. So if you take it out, then it will be like this, y and 1, and that will be y. Okay, so very simple. So this is our option C, that is correct. Okay, option C, that is correct. What about option D? A or B whole bar, A bar, B bar equal to 0. Okay, let's see option D. Let me check here. What about the option D? Okay, option D is saying A or B whole bar, and A bar or B bar whole bar. Okay, so what this will be? This is what option D is saying. So let's apply the De Morgan law. Okay, here what we will get? We will get A bar, B bar. Okay, A bar, B bar, and here we will get what? Here we will get AB. Now that is very simple. Basically, you got A bar, B bar, and that is very simple. That is 0. So yes, option D is also correct. Okay, for this question, which options are correct? The answer will be A, C, D. Okay, this is the answer. Is this clear? Very simple question. Now let's move on. Now let's solve this question. This is a very nice question. Let's solve it. So here the question is saying that you have this circuit, and for this circuit, you have three inputs ABC. These are three 1-bit input, means this is a 1 bit. Either it can be 0 or 1, it can be 0 or 1, it can be 0 or 1. Okay, so remember, the question is saying that you have a circuit. This is our circuit, and in this circuit, there are 1-bit inputs A, B, C. Means A is 0 or 1, B 0 or 1, C 0 or 1. So these are 1-bit inputs, and the output is also 1-bit output. Okay, this output here, you have the output. This is also 1-bit output. Okay. Now the question is saying that the behavior of this circuit is given in this truth table. In this truth table, you can see that in all the rows you have 0 except for these two rows. Only here you have function value equal to 1. Okay, only in these two cases the output will become 1. In all other cases the output is actually 0. The question is saying that you have identical unknown gates. Identical unknown gates X. What is this X? Is this AND gate? Is this XOR gate, XNOR gate? Is this NAND gate? What is this? So very simple question. Understanding this question is very easy. Agree with me? Very simply, you can understand that this is unknown gate. This X. These are two identical unknown gates. Now, what is the best way to solve this question? This type of question. What is the best way to solve this type of question? That is hit and trial. Yes or no? Just put these values and just check. Yes or no? Very simple. Just eliminate the options and you can easily do it. Okay, so let's see this. For example, let me check by this, because here you can see that here the function value is 1. Okay, the function value is 1 here. Now let me check which options will be gone. by this row. Because of this row, which options will be gone? So here I am checking this, hit and trial, remember. Okay, check it. Simple, check it. Okay, let's check it. So you can see that output is 1 and A is 0, B is 0, C is 1. Okay, so now you tell me, remember, this is AND gate. If output of AND gate is 1, then what should be these two inputs? Please tell me. The output of AND gate is 1. So these two inputs, this must be 1, this must be 1, these two must be 1. Okay, so remember, the output of this X must be 1. So can I say that this option is gone? X equal to AND. This option is gone, yes or no? This option is eliminated because if X is AND, if you put AND gate here, then what will happen? Then 1 and 0, that will be 0. Is this clear? So very simple, that because of this row, this option is gone. Which other option is gone? XNOR is also gone. This is also gone. So option A comma B, these are gone. Yes or no? Is this clear? So you can see because of this row, if you check it, because of this, option A be gone. Option A comma B eliminated. Okay, these options are eliminated because of this option. Okay, now we will do something clever. Okay, remember, so far these two options are gone. Now two options are remaining, NAND comma XOR. Now because of this tuple, these options will not go. Yes or no? Okay, you can easily check that because of this tuple, these two options will be satisfying. NAND comma XOR, they will satisfy. Okay, because what is the reason? Let me tell you the reason. Because you can see that one NAND 0, what is that? Let me know. That is also 1. And remember, 1 XOR 0, that is also 1. Okay, so these two options are not gone. Is this clear? Similarly here also. Okay, so these two options, remember, they are not gone. Now, one thing I want to ask you, two options are remaining. Now tell me something clever. Okay, tell me something clever. Two options are remaining options. Remaining options are NAND comma XOR. What will differentiate them? Can anyone tell me which type of inputs will differentiate them? Let me know. NAND comma XOR. Which will differentiate them? Very simple. See, for example, if you have A, B, or maybe I can take XY. If you have XY, what will be X XOR Y? Look at the truth table of X XOR Y. Look at the truth table of X NAND Y. Okay. So remember, this is the symbol for NAND. This is the symbol for NAND. What is the symbol? This is symbol. Okay, so this is the symbol for NAND. Now you can easily see that 0 0 0 0 1 1 0 1 1. Okay, one thing you can see that this is the truth table for XOR. And what is the truth table for NAND? NAND truth table, that is basically 1 0. Sorry, that is 1. NAND means first you do AND, then you complement. Okay, so that will be like this. Yes or no? Now, sorry. Yeah, that is correct. Okay, so what is the only differentiating tuple here? Which tuple will differentiate? You can see this one. Okay, yes or no? Only this will differentiate. Other than this, they are same. Now, what I am saying, tell me which tuple you will take to check. Now, which tuple you will check here in all of them, which you will check. Okay, just make sure that what you should make sure. Remember here, for example, here the input is 1 and this is A. So, and I'm looking for 0 0. If I'm getting this type of input, then I can differentiate. Okay, so what I can do, very simple. I can put this 0 and I can put this 0. Now they are 0 0. Yes or no? Are you getting my point? This is 0, this is 0. Okay, now the inputs are 0 0. So what should be A, what should be B? Please tell me. What should be A, what should be B? A should be 0, B should be 0. Okay, because there is OR gate here. So now basically this is the tuple we need to check. Okay, let's check this. Let's check it. Did you understand why I am checking this tuple? Please tell me, did you understand why I am checking the first tuple? What is the reason I am checking the first tuple? Did you understand? I am checking the first tuple because two options are remaining. The remaining options are already gone. Only two options are remaining. And the differentiating inputs for NAND, comma, XOR. What is this X? This X is this NAND, is this XOR. The differentiating input is 0 0. This is the differentiating input. Okay, because you can see this is XOR, this is NAND. They are always basically same. Yes or no? They are basically same. They will always give you same things. Other than this case, this is the differentiating case. Can I say? This is the differentiating case. Did you understand this point? Please tell me the point that I'm trying to make. Two options are remaining. NAND, comma, XOR, two options are remaining. Now I'm just thinking which input combination will differentiate these two. Yes or no? Which input combination will help me differentiate these two? So very simple, that this input combination 0 0. So that is the reason I am making sure that this is 0 and this is 0. So automatically A is 0, B is 0 because there is OR gate here. So just check this first row. Because of this first row, what will happen? I am checking the first row. Now you tell me, if I put NAND gate, okay, because in the case of NAND, what will happen? In the case of XOR, what will happen? Tell me. In the case of NAND, what will be out? Tell me. In the case of NAND, what will be out? So in the case of NAND, this will give me 1. Okay, yes or no? It out will be 1 and okay, so basically you will have 1 here. Now what you will get here? So you will get 1 here, right? 1 and 1. So that will be 1. So definitely this option is gone, but actually the correct answer is out should be 0. Yes or no? In the case of NAND, you are basically getting out equal to 1, but actually out should be equal to 0. So this option is also gone. So this is also eliminated. Is this clear? Is this point clear to everyone? Please tell me. Let me know, did you understand this point? Okay. So this is a question. This is the question. And finally, the answer will be XOR. This will be the final answer. Okay. See, you might be thinking that where to start the hit and trial. You know that hit and trial, that is a good way to solve this type of question. But where to start this hit and trial? So let me tell you, for example, in this truth table, you can see that almost all the rows are 0 0 0 0. So the good starting point can be these two tuples. Do you agree with me? For this question, the starting point can be these two tuples because they are 1 1. In these two tuples, out equal to 1 1. So this can be your good starting point. And because of this starting point, these two options will be gone. Is this point clear? Yes or no? So this is what I'm telling you, that the best method is hit and trial. But here you can see that you can do some clever thinking that, okay, this all the tuples, the output is equal to 0, but in these two tuples, the output is equal to 1. So this can be your starting point. You can start from here. Then these two options will be gone. You can eliminate these two options. Then you can check, okay, two options are remaining. Only two options are remaining, NAND, comma, XOR. Now again you can apply the clever thinking. You can see what will differentiate NAND, comma, XOR. Yes or no? NAND, comma, XOR, what will differentiate these two? How can I differentiate these two? So for that, the input combination should be 0 0. But here this is fixed. This is fixed. So what I can do? I can make the input combination 0 0 here, 0 0 here. Because this is OR gate, so automatically A will be 0, B will be 0. So like this, some clever thinking you can apply. Are you getting my point? Let me know. Okay. So like this, you can solve this question. This type of questions, they can definitely come in the GATE exam. Let me tell you, this question is taken from Washington University Digital Logic assignment. Okay. So this is actually a very good question. I hope you liked this question. This type of questions, they can definitely come in the GATE exam, and you can solve these questions quite easily. Now let's move on. Now let's solve this question. The inhibition operation, a new operation the question is defining. Okay. See, we already know AND operation, OR operation, XOR operation, many operations we know, but the question is defining a new operation, that is the inhibition operation, also known as AND NOT operation, is a digital logic function. It is a digital logic function where the output is 1 only if first input is 1 and second input is 0. Okay. So very simple. Look at the definition. The inhibition operation. First, let me assume that this is the symbol. Let me assume the symbol is hash. Okay, let me assume. See, the question has already given you the definition of inhibition operation. This is a new operation we are defining. Assume symbol hash. Assume that symbol is hash. Okay. This is the symbol. Now, the operation is like this. What is A hash B? Read the question. The question is saying that this output is 1. Remember, A hash B. This will be 1 only if first input is 1 and second input is 0. Okay, first input is 1 and second input is 0. So remember, this will be 1. A hash B. This is your inhibition operation. This will be 1 when this first input is 1 and second input is 0. When A is 1 and B is 0. So I can write like this. When A is 1 and B is 0. Is this clear? Please tell me. Let me know. See, very simple point. The question has given you the inhibition operation. Okay, this is A hash B. What is this hash? This is your inhibition operation symbol. I am assuming. Inhibition operation symbol assumed. Okay, I am assuming this symbol. I am assuming. Now, here I am saying that the question is telling you what is the behavior. The question is saying that this will be 1. When it will be 1? When it will be 1? This will be 1 when first input is 1, second input is 0. When first input is 1, second input is 0. In this case, it will be 1. Yes or no? Okay, so very simple point. Look at this. The output will be 1. The inhibition operation, this output will be 1 if first input is 1 and the second input is 0. Okay, this is what the question is saying. So in this case, this will be 1. Okay, in other cases, this is 0. Now, here you can easily see from here. Tell me what will be A hash B with help of our simple operators and comma or comma not. Okay, so that will be very simple. Only in this situation, this inhibition operation is 1. Only in this situation you can see. You can see only in this situation there is only word here. Look at this. Okay, so finally what I can say this is same as A and B bar. Is this clear? So remember, this will be 1. A hash B. This will be 1 when A is 1 and B is 0. A is 1 and B is 0 means A and B bar. Okay, this is our inhibition operation. Now you tell me. Now the question is saying, okay, in other words, anyway, this is already basically, in other words, the same thing is written here. Okay, in other words, the output will be 1 when the first input is high and the second input is low. Okay, the same thing is given. Now the question is saying consider two statements. The first statement is the inhibition operation is neither commutative nor associative. Okay, let's check. Is this commutative? Is this associative? First, let me check commutative. Is this commutative? Okay, first check commutative. For commutative, you need to check what? Okay, for commutative, what you need to check? You need to check Is A hash B equal to, is this equal to B hash A? Are they equal? You check it. What is A hash B? Tell me. Tell me what is A hash B? That is A B bar. What is B hash A? A hash B, that is A B bar. Okay. And what is B hash A? That is B A bar. Okay. Are they same? They are not same. So I can say commutative property is no. Okay. Not commutative. Not commutative. Is this clear? Please tell me. Okay. So not commutative. Very simple. So this inhibition operation, this is not commutative. Let's check for associative property. What about associative property? Tell me. What you will check for associative property? You will check A hash B hash C, A hash B hash C. You will check like this, that can I say this and this, they are same? Are they same? Let's check. First of all, you tell me what will be A hash B hash C. What that will be? Okay. See, this is the first. I can do like this. This is the first and this is the second. So it will be like this. Okay. See, let's do the internal. This internal thing will be AB bar hash C. Now this is first, this is second. So it will be AB bar C bar. Okay. Now let's see this one. Let's see A hash B hash C. What this will be? This will be A hash. The internal thing will be BC bar. Okay. Now what it will be? This is the first, this is the second. So it will be A and its complement, BC bar whole complement, right? Yes or no? Because this is first, this is second now. So you will write like this, first and the second complement, the second complement, yes or no? Because remember, this is first, this is second. So you are getting first and second complement. So the same thing here, this is first, this is second. So what you will do? The first as it is and second complement. So what you will get here? You will get A, B bar or C, that you will get AB bar or AC. Are they same? Tell me. Did we get them same? Again, they are not same. See, here you have A, B bar, C bar. Compare this with this. Are they same? Please tell me. Compare these two. No, they are not same. So associative property is also no. Okay. So neither commutative nor associative, this statement is correct. What about the next one? As to exclusive or, that is commutative and associative. Yes, that is correct. We already know XOR operation. This is associative and commutative. Okay, this has both the properties. So which statements are correct? Both statements are correct. Both S1, S2, they are correct. Is this clear? Please tell me. Very simple question. A new operation is defined. This inhibition operation, a new operation is defined. The definition is given to you. This operation, the output of this operation will be 1 only if the first input is 1 and the second input is false. Okay, so this definition of this new operation is already given to you. From this, you can see that this is your operation. A has B equal to AB bar. Now you can check for commutative and associative property. Very simple. Now let's move on. Now let's solve this question. This circuit is given to you and the question is asking for x equal to 1, what should be the combination? So tell me, I want x equal to 1. This is what we want. Okay. Now you tell me this is AND gate, right? Correct. This is our AND gate. So if the output of AND gate is 1, then what should be these three? What should be the input of AND gate? The output of AND gate is 1. If I want to make the output of AND gate 1, then these three should be 1, 1, 1. They should be 1, 1, 1. The input should be all ones. Correct? Okay. Now let's see. So one thing is clear, that C must be 1. This thing is clear, that C must be 1. So option A is gone. Option C is gone. Yes or no? C must be 1 because this is the direct connection. Okay, you can see this is the direct connection. So that is the reason I can say C definitely must be 1. Okay. Now, this is our XNOR gate. Okay, what is this? This is XNOR gate and this is XOR gate. Now you tell me. So what is 1 XNOR B? What is that? Tell me. What is 1 XNOR B? Let me know. Or I can say B XNOR 1. Both are same. B XNOR 1. What that will be? Let me know. So very simple. We already know that a x XNOR y, that is equal to xy or x bar y bar. So you can apply the same thing here. Okay, this will be B1 or B bar 1 bar. So finally, this will be same as B. Okay, yes or no? So remember, this output actually will be same as B. Okay, so B also must be 1. Correct? So two options are remaining. B also must be 1. So this option is gone and this option is correct. Okay, you can cross verify. Let's cross verify. If I put A equal to 0, B equal to 1, C equal to 1, if I put these, then what will be your X? Then what will be your X? Very simple. In this case, remember A is 0, B is 1. A is 0, B is 1. So this XOR also will be 1. So in this case, X will be 1. So your answer for this question will be option D. Is this clear? So very simple question. Now let's move on. Now let's solve this question. The complement of function f1, what is that? Okay, so let's solve it. Function f1 is given to you, f1, and that is a b bar whole bar or c d bar or ac bar. Okay, so this is the function that is given to you. Now let's solve it. First, you can apply the De Morgan law here. What you will get? You will basically get a bar or b. This is what you will get, or c. Okay, this whole thing and with d bar or ac bar. Now what you will get? What is the next thing? That will be basically you can see it will be a bar d or bd, sorry, a bar d bar. Okay, this will be basically a bar d bar or b d bar or c d bar or a c bar. Okay, this is f1. Actually, what the question is asking? The question is asking the complement of this function. The question was asking what is complement of f1. Okay, but we got f1 here. But actually the question is asking the complement of f1. So can we simplify this f1 from here? Tell me. Is it possible to simplify this f1 from here? We need to find the complement of f1. That is what we need to find. Okay. So actually the question is asking complement of f1. So what we can do, this is what we can do. f1 is given to you, that is a b bar whole bar or c d bar or ac bar. Okay, this is the f1, but the question is asking f1 complement. Okay, the question is asking what is f1 complement. So let's do the complement of this whole thing. Let me do the complement of this whole thing. Okay, is this clear? So let me do the complement of this whole thing. If I do the complement of this whole thing, then what I will get? Basically, I am finding f1 complement. So if I do this, then you can apply the De Morgan law. So you will get complement of this and complement of this. Okay, so that will be, okay, let's apply the De Morgan law. So if you apply the De Morgan law, then what will happen? I can say that complement of this one, let's see the options. Okay, these are the options, so no problem. So let's apply the De Morgan law. If you apply the De Morgan law, then you will get this complement. Okay, let's do the complement of this one. So that will be a b bar. Okay, the complement of this, remember, very simple. Okay, let's do the complement of this. This will become and, the complement of this will become c bar. Now this and will become or, so it will become or d. Correct? Okay, this will become and, here the complement will become a bar or c. So this is what you will get. Is this clear? Please tell me. We are applying the De Morgan law. In the De Morgan law, what will happen? Very simple point. This or will become and, this or will become this and will become or. Okay, the complement of this, that will be ab bar itself. Okay, and this will be c bar, and you can see this will be d. So very simple. This is your f1 complement. This is the function complement. Now let's solve it further. What you will get? You can apply. Okay, you can just do their and. So what you will get? You will get a b bar c bar. Okay, this a b bar c bar with a bar, or a b bar c bar with c, or d with a bar, or d with c. Correct? Yes or no? Now this will be 0, this will be 0, this will be 0. So your final answer, what that will be? So your final answer will be a bar d or cd. A bar d or cd. This will be your final answer. Okay, so for this question, the answer will be a bar d or cd. Answer will be option A. Is this point clear? See, very simple question. The function f1 is given to you, but the question is asking complement. Remember, the question is not asking f1. The question is asking what is f1 complement. Okay, so very simple. You just find what is f1 complement. F1 is already given to you. You find f1 complement with help of De Morgan law. Apply the De Morgan law. Okay, so you can see here, this is f1. Okay, if you apply the De Morgan law, what will happen? Let me tell you. If you apply the De Morgan law, so this is your function f1. Now f1 complement. So for f1 complement, okay, f1 complement means whole complement. Okay, you are doing the whole complement. So if I do the whole complement, then what will happen? See, this or will become and. Okay, this or, this will become and. So here you have one thing, and here you have the complement of this. So that will be a bar or c. Very simple. Now you will do the complement of this one. Okay, the complement of this one. So let's see, this and will become or. This and will become or, and this d complement will become d. Okay. Now again, what you have inside here something. Now let's do the complement of this one. Okay, if you do the complement of this, then what will happen? The complement of this will be ab bar. This or will become and this c will become c bar. So finally, what you are getting, you are getting, finally, this is what you are getting. You are getting a b bar c bar or d and a bar or c. This is what you are getting, right? A b bar c bar or d. Okay, so if you simplify this, you will get a bar d or cd. This is the final answer you will get. Very simple. So the answer will be option A for this question. Now let's move on. Now let's solve this question. Which of the following Boolean equations are correct? Some Boolean equations are given to you. Which of them are correct? Let's check. The first equation, is this correct? A bar, C bar, whole bar. Okay, let's check the first equation. This is a bar, c bar, whole bar, and a or c bar, or b, or b bar or c bar, b bar or c bar whole bar. Okay, b bar or c bar whole bar. This is given to you. Now let's see, is this equal to, is this equal to a or b? Are we getting a or b? So let's first simplify this. What you can get here, you can apply the De Morgan law here. What it will be, a bar c bar whole bar, that is basically a or c, and a or c bar, correct? Or b, you can apply the De Morgan law here also. Okay, what you will get, you will get bc. Now you can apply the absorption law, so this will be b, this will be same as b, correct? Okay, this will be same as b. So what you will get here, here you can multiply them, basically you can do their and you can apply the distributive property. So you will get a or a, that is a or c bar, that is ac bar. Sorry, a or a and a and a will be a and c bar will be ac bar, c and a will be ac, and c and c bar, that will be 0. This is b here. Okay, you can apply the absorption law here, this will be a or 0 or b, so that will be a or b. So yes, option A is correct. Okay, the question is asking which option is correct. Option A is definitely correct. What about the option B? A bar C, A B bar. Okay, let's see option B. Option B is saying A bar C or A B bar or A or C bar or A B. Okay, what this is? So let's simplify, very simple. A bar C or A B bar. You can apply the De Morgan law here. Okay, here you can apply the De Morgan law. So what you will get? You will get A bar C bar or AB. Correct. Now let's see A bar C, A bar C bar. What I can write like this? Okay, this will be what? A bar C or A bar C bar. You can take A bar out. So this is same as A bar. Okay, this will be same as A bar. Or here you have A bar B, sorry, A B bar or A B. You can take A out. So this will be same as A. Okay, so finally what you have A bar or A, that is same as 1. So yes, this option is also correct. What about the next option? Let's see option number C. What is option number C? That is C, AB or AB bar or A or B whole bar C. Okay, so let's simplify this. Again, what you will get? You will get ABC or AB bar C, or you can apply the De Morgan law here. Here you can apply the De Morgan law. So what you will get? You will get A bar B bar C. This is what you will get. Now you can easily check that these two you can take AC out. From these two you can take AC out. Okay, so it will be AC or A bar B bar C. What you can do? Here you can take C out. If you take C out, it will be A or A bar B bar. Okay. Now remember, there is this rule that X or X bar Y, that is same as, you can cancel this X bar, and that is same as X or Y. Okay. Yes or no? This rule is there. This is an important law that X or X bar Y. So you can cancel this X bar. So here also A or A bar B. So you can cancel this A bar. So this A bar you can cancel, and you will get CA or CB bar. CA or CB bar. Okay. So this option C, this is wrong, right? Yes or no? Is this clear? In option C, you are getting this equation. Okay. So option C, that is definitely wrong. This will be your option C. So option C is wrong. Okay. What about the option D? What about this? Let's check option D. In option D, you have B or B bar whole bar. You tell me what is B or B bar? Tell me what is B or B bar whole bar? What that will be? Whole bar. What that will be? That will be 0 whole bar. And that will be same as, sorry, that will be 1 whole bar. Because B or B bar, that will be 1 bar, that is 0. Yes or no? Because this thing will be 1. B or B bar, that will be 1. 1 whole bar, that will be 0. Okay. So this is very simple. This is actually, I can say option D. You have 0 or, okay, 0 or something, right? So ultimately, you basically have just this A or C, A or C bar. You have this A or C, A or C bar, okay, and A bar, A bar or B. Okay, let's see what this will be equal to. So here you can easily see what this is. Okay, if you simplify this, this will give you A. Okay, let me tell you, this will give you A. You can simplify this. And what you will get here, see, you will get here A bar or A bar B. You can apply the absorption law. So here you will get A bar. So finally you will get A bar, and that is equal to 0. So that is equal to 0. Yes, this is correct. Okay, so option D is also correct. For this question, which options are correct? Answer will be ABD. Which equations are correct? So the answer will be ABD. For this question, answer will be option ABD. Okay. So these are all the questions that we have done. Please tell me, did you understand everything? Let me know. So this is our weekly quiz solutions. Okay, let me know if you have any doubt. Did you understand each and every question, each and every solution? These are the 10 questions. 2-3 questions were very good questions. The inhibition question, a new operation was defined, inhibition. That question was very good. Another question, the circuit was given to you. The question was asking, what is this X? The logic gate X. Okay. So this type of 2-3 very good questions were there. And the remaining questions, they were standard questions, very frequent questions. Okay. So I hope you understood the complete solution of this weekly quiz. Okay. Thank you, everyone.